Welcome to Student to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Hello, today we will be doing a student-to-student review of Euler's method. Our first example is a multiple choice problem. Using the differential equation dy dx equals x times the quantity 2 minus y, and given the initial condition f of 0 equals 8, use Euler's method to find f of 1 using two equal steps. The important parts to remember are the differential equation, the initial condition, and what we need to find. The best way to do Euler's method is to arrange it in a table. You can work down a sheet of paper, but making a table makes it much simpler to keep track of. Our options for the multiple choice are A, 3.5, B, 8, C, 6.5, and D, 11. Our first step is to put our initial conditions into the table, x equals 0 and y equals 8. Our next step is to solve for the differential equation at our initial position by plugging 0 and 8 into the differential equation. This equals 0. Next, we need to make our first x step. We are trying to get from 0 to 1 using two equal steps, so each step will be 1/2. We must now solve for y using our x position of 1/2. The way we find y at x equals 1/2 is by plugging our initial position of y and adding that to our change in y. This gets us a result of our new y equaling 8, which is the same as it was before. This makes sense because the slope, or the differential equation, was 0, so y did not increase. We now solve for the differential equation at our new position, 0.58, plug in the variables again, and solve. The differential equation is now -3. We make our next step in the x direction, plugging in x equals 1. Then we solve for y again using our old position of y, f at 0.5, and our change in y again. Our new f of 1 equals 6.5, or y equals 6.5. Compare this to our multiple choice answers, and we see the correct answer is C, 6.5. We'll now be moving on to the FRQ, free response, question example. The question we'll be using is question number 5 from the 2013 BC FRQ. Question 5 reads, consider the differential equation dy over dx equals y squared times the quantity 2x plus 2. Let y equals f of x be the particular solution to the differential equation with initial condition f of 0 equals -1. Part A of question 5 is irrelevant to Euler's method, so we'll cross that out. Part B, the actual question, says, use Euler's method starting at x equals 0 with two steps of equal size to approximate f of 1/2. I'll retype this into clearer text so it's easier to read. Again, we start by plugging our initial conditions into the table, x equals 0 and y equals -1. Then we solve for our differential equation at that initial position, plugging in our variables and solving. The differential equation, or slope, is 2. Our next job is to put the step for x. We're going from 0 to 1/2 using 2 even steps, so the first step for x is 1/4. Then we solve for y again, using our initial condition and our differential equation that we solved, plugging the numbers in and getting our new y value of -1/2. Then we solve for the differential equation again at this new point, plugging our variables in again and solving to get 5/8. Our final step for x is going from 1/4 to 1/2, and we must solve for y again using our previous position and adding the change. However, when you reach this point, you should stop on the real AP test. The goals for this question is to approximate f of 1/2. At this point, we have f of 1/2 equaling a series of numbers and symbols, and there is no variables in the equation. On the actual AP test, this is where you should stop because it is technically a correct answer, and if you continue, it's a very complicated fractions and complicated stuff that you shouldn't continue to add up, just in case you accidentally make a mistake. However, I do show the rest of the answer. It is worked out to be -16 30-seconds plus 5 30-seconds, which gets a final result of -11 30-seconds. That's been our review for Euler's method. Thanks for watching and good luck on your upcoming AP test.